Hello everyone, welcome to In 5 Minutes. In this video we are going to see type 2b of making an equation exact. So in our previous type we saw how to find an integrating factor. In this, if our equation is given m dx plus n dy equal to 0, if we find partial derivative of n and partial derivative of n and these two are not equal, then our equation is not exact. So to make this equation exact, we multiply by integrating factor, but this integrating factor differs for each type. So for type 2a, we saw the integrating factor is 1 upon mx minus 1 upon ny. This is valued only if our equation can be represented as in this form, as we already know. So this integrating factor is only valid for the equation having this form. But now in type 2b, if this m dx plus n dy equal to 0 is not exact, and if this equation is homogeneous equation, then our integrating factor is given by 1 upon mx plus ny. But some of might want to know what is homogeneous equation. Homogeneous equation is equations which have constant degrees. That is, every term in this equation have the same degrees, like x cube x into y square plus y into x cube. So as you can see here the degree of x is 3, here degree of x is 1, and here degree of y is 2. So total degree is 3. Here also the degree is 3. So throughout the equation degree of terms is constant. Then this type of equation is called as homogeneous equation. So when our equation is not exact but it is of the form of homogeneous equation, then our integrating factor is given by 1 upon mx plus ny. Then we multiply this integrating factor with this, and we will follow the same procedure as we used to follow for other type of problems. So this equation will be more cleared when we solve the problem on this. So the question is, solve this. So this equation is of the form m dx plus n dy equal to 0. So what is m? M is this value, which is x square minus 3xy plus 2y square. What is n? N is this value. I am going to multiply this x with each term. So 3x square minus 2xy. Now I am going to find the partial derivative of n with respect to y and partial derivative of n with respect to x. Here the x will be constant, so this part will be neglected, and minus 3x is constant. Derivative of y is 1 plus derivative of y square is into 2y. So this is written as minus 3x plus 4y. Now we are going to calculate the partial derivative of n with respect to x. Here y will be constant, so this 3 is constant, and derivative of x square is 2 into x, and derivative of x is 1, and 2y is constant. So this is written as 6x minus 2y. As you can see, these two equations are not equal, so our given equation is not exact differential equation. But as you can see in this equation, here the power is 2, here the power of x is 1 and y is 1, so the total power is 2. Here also the power of y square is 2. So in this equation each term has the power of 2. Similarly, here the power is x square, and here the power is x into y, so 2. So throughout this equation the power is constant. So this equation is nothing but our homogeneous equation. For homogeneous equation, the integrating factor is given by 1 upon mx plus 1 upon ny. So now we are going to calculate the integrating factor. What is m? M is x square minus 3xy plus 2y square multiplied by this x, plus what is n? N is 3x square minus 2xy multiplied by this y. If I take this x inside the bracket and this y also inside this bracket, then we will get x cube minus 3x square y plus 2xy square plus 3x square y minus 2xy square. So minus 3x square y will get cancelled with this, and 2xy square will cancel with this, so we are remain only with 1 upon x cube. So our integrating factor is this value. Now we will multiply this integrating factor with our given equation. So this is our given equation, and we will multiply this given equation by integrating factor. So we are going to multiply this integrating factor with each term. So x square upon x cube minus 3xy upon x cube plus 2y square upon x cube and this whole term is multiplied by dx plus 3x square upon x cube minus 2xy upon x cube, and this whole term is multiplied by dy equal to 0. This is nothing but multiplying with each term, so this x square get cancelled and here it is remaining only x. So this x and this x will become x square. Here nothing to cancel, x square will get cancelled, so here we are remain only with the x will cancel, and here we are remain only with x square. So our new equation will become 1 upon x minus y by x square plus 2y square upon x cube into dx plus 3 by x minus 2y by x square into dy equal to 0. So this is our new m1 and this is our new n1, and now we are again going to find the partial derivative of m1 and n1.